What is Werner's theory of coordination compounds?
History. In 1893, Werner produced a theory to explain the structures, formation and nature of bonding in the coordination compounds. This theory is known as Werner's theory of coordination compounds. Werner was the first inorganic chemist to be awarded the Nobel Prize for Chemistry in 1913. He studied many complex compounds obtained from the reaction between cobalt chloride and ammonia. The postulate of Werner's theory. The central metals of coordination compounds exhibit two types of valencies. Primary valency. Secondary valency. 1. Primary valency. Primary valencies are those which a metal exhibits in the formation of simple salts, e.g. Cocol 3, Nacl, CuSO4 etc. In modern terminology, it represents the oxidation number of metal. E.g. the primary valencies of Co in Cocol 3 is 3, and oxidation state plus 3. Similarly, for Nacl, oxidation state of Na is plus 1, for CuSO4, oxidation state of Cu is plus 2. The primary valencies are ionizable. These are written outside the coordination sphere. These are non-directional and do not give any geometry to complex compound.
Similarly, for sodium chloride, oxidation state of Na is plus 1, for copper 2 sulfate, oxidation state of Cu is plus 2. The primary valencies are ionizable. These are written outside the coordination sphere. These are non-directional and do not give any geometry to complex compound. Example: Co, NH3, 6, Cl3, number of primary valencies 3, oxidation state plus 3.
Secondary valency. The secondary valency of metals is either by negative ions or neutral molecules or both. In modern terminology, it represents the coordination number of the metal. Secondary valencies are written inside the coordination sphere. These are directional in nature and give definite geometry to the complex. These are non-ionizable. Example: County NH3, 6, Cl3 coordination number is 6.
Explanation of structure and properties on the basis of Werner's theory. Werner explained the structure and properties of following four complexes of Co, 3, chloride with ammonia.
Structure and properties. Werner added the above four cobalt 3 complexes in table with an excess silver nitrate solution, which resulted in different amounts of silver chloride precipitate. He concluded that in Cocol 3.6 NH3, 3 Cl ions react with 3 silver ion form 3 silver chloride precipitates which act as primary valency and 6 NH3 molecules act as secondary valency. Thus in modern term the compound is written as Co NH3, 6 Cl3. For Cocol 3.4 NH3, 1 Cl is primary valency, 2 Cl and 4 NH3 is secondary valency. So the compound is Co NH3, 5 Cl2 Cl. For Cocol 3.3 NH3, all 3 Cl and 3 NH3 ion act as secondary valency, so the compound is Co NH3, 5 Cl3. He represents the primary valencies by dotted lines and secondary valencies by solid line.
Evidence in favor of Werner's theory. 1. Cryoscopic measurement. The cryoscopic measurement, i.e., measurement of depression in freezing point, gives the number of ions formed by the dissociation of an ionic compound. The depression in freezing point is a colligative property and depends upon the number of particles in the solution. The greater the number of particles, the more will be the freezing point.
2. Electrical conductance measurement. The conductance of solution depends upon the numbers of charged particles present in that solution. Co NH3, 6 Cl3 right pointing arrow, Co NH3, 6 ++ 3 Cl. Co NH3, 5 Cl, Cl2 right pointing arrow, Co NH3, 5 Cl ++ 2 Cl. Co NH3, 4 Cl2, Cl right pointing arrow, Co NH3, 4 Cl2 ++ Cl. So that the molar conductance of the compound should be the following order, which also satisfies the observed conductance value. Co NH3, 6 Cl3 greater than Co NH3, 5 Cl, Cl2 greater than Co NH3, 4 Cl2, Cl greater than Co NH3, 3 Cl3.
Precipitation reaction. On the addition of silver nitrate solution, with chloride complex, the chloride ions which present outside the coordination sphere undergo precipitation reaction. As the number of chloride ions present outside the sphere increases, the number of formation of precipitates increases and vice versa. Limitation of Werner's theory. Though Werner explained some properties of the coordination compound, he failed to explain the color of the coordinate compound. He could not explain the magnetic and optical properties of coordination compounds. He could not answer the question, why does the coordination sphere have a definite geometry?
Heteroleptic complex. Heteroleptic complexes. Heteroleptic complexes are those in which a metal ion is surrounded by more than one type of ligand. Heteroleptic complexes are those in which the metal atom or ion is connected to more than one type of ligand. These are complexes in which a metal is bonded solely by OR-type ligands, such as Co-NH3,6,3+ complexes. Heteroleptic. These are complexes in which a metal is bound by multiple types of ligands, such as Co-NH3,4,Cl2+.